If you install a wind turbine with an 80-meter diameter rotor on top of a 70-meter high steel column, you can use high-altitude wind currents to drive the turbine and generate increasing amounts of electricity. And ancient records note that the higher above the ground you are, the stronger the wind becomes, allowing larger turbines to produce more power. But a column that is too long cannot create stronger, effective wind forces. So the clever you replace the column with a 200-meter tall twin tower building and cut an opening straight through its center, then connect a steel sky bridge between the two sides of the opening on which a wind turbine can be mounted, using the high-altitude airflow that passes through the opening to generate electricity. To obtain more clean energy, you extend and enlarge the opening and add more turbines at different heights. But because wind directions at high altitudes change frequently, it is difficult to ensure sufficient head-on wind. So you rotate the two towers 37 degrees toward the prevailing wind direction, and using the airflow acceleration principle of aircraft wings, design the buildings in a blade-like shape, creating a large three-dimensional wind funneling system that guides winds from different directions and converts them into stronger, more focused airflow to drive the turbines. However, turbines at different heights bear very different wind loads, which can easily lead to damage or even failure of the higher turbines. So you cleverly taper the two towers slightly, allowing the wind-catching surface area on the sides of the buildings to gradually decrease with height, balancing the wind forces acting on turbines at different levels. And in this way, you obtain a building that can generate its own electricity, taking a small step toward protecting the Earth. Congratulations! You have designed the Bahrain World Trade Center.